Hi, my name is Sam Graham. I'm going to be talking about the SIE 555 project, low-cost air traffic control radar for rural areas. And I'm going to be talking about the Matlab portion, as Jeff and Josh and Alex should have talked about the other portions of the presentation by this point, at this point in time. So essentially, we found a Matlab model, a Matlab example for an air traffic control scenario, and it had an airport surveillance radar that is commonly used at like international airports. So we had to modify our simulation to work within the Class G airspace. So essentially, the scenario has three aircraft traveling at various speeds, and the RCS of each plane was adjusted to compensate for the sensitivity of the radar. So in our simulation, I'll show that we'll have an incoming aircraft, a outgoing aircraft, and then an aircraft just tangential of the airspace. And so then if you look at the code for the air traffic control example, it has a radar, a monostatic radar sensor that we used, and the main parameters that we adjusted with that was the detection probability, which defines the probability of detecting a target with a radar crest section reference RCS and at that reference detection range right here. And the range resolution was 135 meters, okay? And so these were the main parameters that we changed to the monostatic radar. So I'm gonna go ahead and live demo this right now. So here's our code. As I said, we modified a few things within the monostatic radar. We also gave each aircraft we had to change the position so that it'd be within 15 kilometers of our radar, which is one of the specs. And then we also gave it a RCS signature that I haven't quite got it working properly with the signature, and I think it's a Matlab issue. So I'm emailing the Matlab guys back and forth, but I think they have a bug in their code somewhere, because when I change this, it's not changing as it should. But if I go ahead and I modify the reference RCS and the reference range and then the detection of probability, then I'm able to get different signatures from the aircraft. So let me go ahead and run this and see what it's doing. Okay, so essentially the guy in the middle is our airport tower, and as you can see, he has a beam here. It's a mechanically steered radar sensor, and these are my three different planes. And so as you can see, as the radar goes across the target, it makes this little blue circle, and that means it's a detection. So these guys are within the 15-kilometer radius, and then as you can see, this guy to the left here, he wasn't detected because there was no blue dot on him, and that's because he's actually just outside of the 15-kilometer range. And so I just wanted to show an example of where we're actually getting detections and creating tracks on these two targets that are close. So on the next go around here, it's actually going to create tracks, okay, just like that, and those are squares. And so essentially these tracks have information in them, altitude information, heading information, and at the end I'll show you guys the results, the table that's outputted from this. So it will run. I think it got one or two more rotations after this. Just have to sit tight for a sec.